Chapter 10, Geometry for Math 121. We're looking at the fourth section. This is area and circumference. And so in this one, we're going to look at area formulas and compute the area of plane regions and solve applied problems using formulas for circumference, circle circumference, and area. All right, so we're going to do both of those. All right, so an area of a rectangle and a square. This should be fairly familiar to us as you're following along. Area of a rectangle is just base times height or length times width. And that's true of a square. With a special case of a square, just notice that your L and W are the same length, which is why uh, you get this S squared or the side squared. All right, so solving problems involving this relationship. So I have a rectangle with these composite geometries here. So if you can kind of see, you can kind of break it up into either a rectangle along this one and break it this way, or we can break up the direction this way. And so they chose in this example, we're going to have a rectangle here and a rectangle here. Doing it this way is more helpful because you already know the length of this side here and this side here. So instead of breaking it up this way, you would have to add in this 3 feet to consider this entire length here. And then you would know. So it's give or take, but this one's constructed pretty nicely so you know that the area of this one would be 3 times the 13 square feet. So whatever 3 times 13 is, which is 39. Okay, so that's 39 square feet. And then notice this one, since we're going all the way up to here, we got to add. So it's really, this height here is 6 plus the 3 feet, which is what it's indicating here. So that's where that's coming from. It's because the 6 feet's up to here, but we still have 3 more feet from this side. Okay, so it's going to be 6 plus 3 gives us the height here. And so this area here is 3, that's the base, times 9. So this is going to be 27 square feet. Okay. Whereas this one is 39 square feet. So the total then, adding those together, is 39 plus 27, or 66 square feet. All right, area of a parallelogram is actually just base times height. And this is always true, and it's still kind of trippy, but the reason is because when you push over this rectangle, so if you imagine originally it was this rectangle, right? And then someone comes along and pushes it this direction, right? So the issue is that its height actually never changes, right? So its height is still the same, even though it's been pushed this direction. So it's kind of like a shear force, right? It's pushing it this way. And so the amount of height that has been, or the amount of area, I should say, that's missing in this place has been added to over here. And so that's what this is showing. That originally it looked like this, and someone came along and pushed it maybe like that, and right, and so it formed this, but it's like cutting, that's the equivalent of like cutting off this area and attaching it over here. So that's why the area of a parallelogram is still base times height, just like a rectangle, even though it may not look like it. All right, so we can use that using that to find the area of this parallelogram here. And so parallelograms have opposite sides parallel, just in case it wasn't clear. So here we know the height is 4, we're given that, and its base is 8. So the area here is 32 square centimeters, which is what you see there. Okay, and the area of a triangle is exactly the area of a rectangle that's been cut in half. So there is some, in this case, you could draw a parallelogram or draw an actual rectangle. So that you can see that there is a effect. Okay, so using the area triangle, so we're given that the height is 10. We're given that the base is 16. So half base times height is 60, or sorry, it's 80 square meters. And then the area of a trapezoid, this one, I don't know. It's this relationship. I've done enough of them now that I kind of know what it is, but I still break it down. I can still see it as breaking it down into you have 2 rectangles, sorry, 2 triangles and then a rectangle. I double the area of the one rectangle though, because it's the same on both sides, provided that these are the same. Okay, so anyways, it's a half base times height. That's the area of the yellow triangle, which is a nice way of seeing it, and then plus half base times height times that of the by a triangle. So that's another way of seeing it. And I like this composite vision effect. Probably my favorite thing from this chapter is how they've broken this one down. Okay, so finding the area then of this trapezoid, it's the relationship of 1/2 the height, which is 13, and then this a plus b is the sum of the two bases. So 32 plus, say the lower one is 46. So 46 plus 32, multiply that by 13 and then divide by 2, you get 507 square feet. All right, a circle, by definition, oh, that's an amazing circle. A circle has a radius, which is the fixed distance from a common locus of points, and its diameter is the distance all the way across, from one edge to the other. So the area of a circle then is equal to sorry, I should say the circumference in this case is equal to the circumference times pi. That gives you then the or another way of saying that would be circumference is equal to 2 pi r, where the 2r is there's a radius here and a radius here. Adding these together, you get 2r, which is the diameter. All right, a circle of an area of a circle, that's what I was trying to say, is pi r squared. So we can arrive at that a couple different ways, but taking it for the moment, that is the result. Knowing the radius, and then we can square that length, so it's 64, and then multiplying it by pi, which is about 3.14. You can get roughly the area as 201 square inches for this pizza example, and then do the same thing, you get 50 square inches roughly for the second one. Okay. Notice that even though the radius is twice as long between the two pizzas, the area is 4 times as large, and that's because you're squaring that distance. So this ratio gets squared, and so you get 4 times the amount. All right. The problem solving using the formula circles area. So using that for each pizza, the price per square inch is found by dividing. So this is asking about a better deal, and so you have 15 divided by 64 gives you about 7 cents per square inch. And for the medium pizza, it's about 15 cents. So the large pizza is the better buy. In other words, you get more pizza for less money. Okay. All right. I hope that was helpful, and I'll see you in the next video.